Hello everyone. These are the topics which we are going to cover in today's class. In this lecture, we are going to discuss about basics of AWS networking. It will be a good learning experience if you are new to AWS, or even if you have some basic idea about AWS, then it will be a good revision for you. In this lecture, we are going to discuss about what is AWS VPC, what are subnets, what is Internet Gateway, and how root table works, and how we can access Internet from the EC2 machine which is in private subnet, and also how we can analyze our traffic using AWS VPC Flow. So let us jump into our first lecture, going to be about Amazon VPC and its component. So this is the architecture which we are going to follow in our today's lab for Amazon VPC. So we are going to deploy one virtual private cloud, and inside it we will be deploying two subnets, out of which one will be the public subnet and one will be the private subnet. EC2 machine inside the public subnet will be able to access the internet, or you can access them using the public IP with the help of Internet Gateway. And during this lab, we will also see how to modify the root tables so that we can access the public machine from the outside, as well as how we can reach out to the private EC2 instance by using the public EC2 machine as a jump box. And during the lab, we will also see what are security groups and how to modify them to restrict or allow the traffic through various EC2 ports. Here are some points which will help you to understand the VPC in a better way. Here I am in my AWS console home. So click on services, and from the left hand side menu scroll down, and under network and content delivery go to the VPC. Here you can change the region where you want to deploy your resources or your VPC. So here I am selecting US East 2, that means Ohio region. I will hit on create VPC. Here I have two options, one is VPC only and one is saying VPC and more. VPC and more is kind of a semi-automated way where it will create a VPC for you, and whatever the subnets and root tables are required, it will create for you. But as we want to learn everything from the scratch, so I will be going with the VPC only option. Here, give your VPC some meaningful name. In many organizations, what happened? They implement some policies in various clouds like AWS, Azure, Google Cloud, etc. that you have to adhere to some naming convention, and if you don't follow that, you won't be allowed to deploy that particular resource. Say something like VPC and the application name and the region name and something like that. So let me give some meaningful name. Let's say VPC, and this for the web application, and this is for the Ohio region, so OH and 01. Here I will be selecting only IPv4 CIDR block, and here whatever the CIDR we want to go with the for our VPC. So here I will be providing 10.0.0.0/16 as per our lab architecture which we discussed earlier. Here I will be keeping tenancy as a default, and here you can add various tags. Tags is basically a meta information about that particular resource, and it is a very useful and efficient way in which you can segregate your resources when it comes to your billing or your resource utilization, etc. So suppose any team XYZ is responsible for the maintenance and for using this resource, then you can give it a team name, and also this resource is used by this particular web application, you can give that as well. So it depends on your requirements and also to the company policies. Here also many organizations implement tagging policy where you have to adhere to it and you have to give the particular tags and the respective values. And if you are not going to give it, you won't be allowed to create the particular resource. So as of now, to keep things simple, I will remove all the custom tags and only will keep the default one, that is provided by Amazon. That means name is equal to the resource name. And now hit on create VPC. It will take a minute or so to get our VPC deployed and be ready for us. Go to your VPCs. I can see my VPC has been created. And with our newly created VPC, I can see one more VPC which is already present. So what happens? AWS creates one VPC by default in each region so that it's easier for you to go and deploy your resources. But as we don't need this and we want to learn everything from the scratch, so we'll be deleting this VPC and only using our custom VPC. And if I go to the subnets, I can see 3 subnets in each availability zone which is associated with our default VPC. You can also rename your VPC by clicking on the pencil icon and give it a name of your choice. And also on selecting this VPC and click on action, and here how you can delete the VPC. So acknowledge and confirm by typing delete default VPC and click on delete. Also, if you go to the subnets, you won't find the existing subnet. So here we will be creating a new subnet under our newly created VPC. Once you select the VPC, it will give you the further subnet settings. So here you can give it a name to your subnet. So we will be naming it as a public subnet as per our architecture which we discussed earlier. You can select any of the availability zone. So as of now, I will be going with the US East 2A availability zone. So here is the simple way in which you calculate how many IP addresses will be available in a CIDR block. Give the CIDR block for the subnet as per your choice, but it should be a part of the VPC CIDR block. We'll go as per our architecture and we'll hit on create subnet. Here are a few points about private subnet. Now we will create private subnet. So again hit on create subnet and select our VPC. And again give it a meaningful name. This time I will be selecting availability zone as 2B. And give it a CIDR range which should be a part of VPC CIDR range. Also, it shouldn't conflict with our public subnet CIDR range. And hit on create subnet. So now we have both public and private subnet in place. Now we will create EC2 instances for the respective subnets. So from the services menu, scroll down and go to the compute, and from there go to the EC2. And also you can bookmark EC2 by clicking on star, so it will start appearing as your favorite in your console home. Here are some points about EC2. Now this is EC2 dashboard. You can see the instances running as well as the placement group, instances, etc. and auto scaling group, so which we are going to talk later. But as of now, create on launch instance. I will be naming it as a EC2A as per our lab architecture. And then I will be choosing the AMI. AMI is Amazon Machine Image. So basically it's a OS image containing operating system and some predefined software. So we will discuss about AMI in some other lecture. So I will go with the Amazon Linux 2 AMI. This AMI is eligible for the free tier. And then I will be choosing the instance type. I will be going with the T2 micro, which is also eligible for the free tier eligible, as you can see it on the screen. Now I have to select a key pair login. So for this region, I don't have any existing key pair in my account. So every region, so when you can create a key pair login, you can use it for other instances as well in the same account and in the same region. So I will be creating here a new one. Give it a some meaningful name. Key pair type, I will be going with the RSA. And private key file format, there are two options. One is the PEM key and one is the PPK. So PEM key mostly you use when you do SSH from the Linux machine, and PPK will be used by the PuTTY software, which is a third-party software which you can use it in Windows to log in or to SSH into the EC2 machine. And also you can convert PEM key to the PPK key using the PuTTY key file generator. I will go with the private key file format as a PEM type because I will be using the same key to connect from one EC2 to another EC2 machine, and I will be converting this PEM key to the PPK key, which I can use with the PuTTY using the PuTTY software. This I am going to show you. So click on create key pair and it will download a PEM key file in your workstation. So hit on create key pair. Now in the network settings, click on edit. So here I will be, you can select the VPC and the subnet. So as per the diagram, EC2A should go in the public subnet. And I will be enabling the auto assign public IP, which will be assigned by AWS. Otherwise, we have to associate one elastic IP to it so that we can connect to this machine using the public IP. Here are some points about security group. Next comes the security group. Here I will be creating a new security group. So security group is a firewall in which you can filter the traffic at the TCP IP layer on the respective ports to the EC2 instances. In the security group, you can only allow the traffic. Rest of the traffic which you have not mentioned will be automatically denied. Here our EC2 launch instance wizard is giving us an option to allow the SSH traffic from anywhere on port 22. Here you can also define a custom CIDR range which we are going to see later. But as of now we are going with the anywhere, that means 0000 CIDR range, so that we can SSH into the machine using the public IP. Now scroll down further. Give some name to your security group and as well as the description of your security group. Here you can add further rule like for HTTP traffic or other traffic, etc., depending on the port numbers. Here I will be keeping other settings as default, and I want the number of instances which should be equal to 1, because as per our architecture there should be one EC2 instance in the public subnet. Here you can see the free tier information which says free tier, your free tier eligibility is 750 hours per calendar month for the EC2 instance. If you have two EC2 instances running all the time, then it will be 750 by 2 hours. So hit on launch instance and go to the instances, and as you can see our EC2A is initializing and it will take couple of minutes to get ready. And here you can see various information like what is the private IP address, what is the public IP address, what is the network it belongs to, etc., storage, other things which we are going to discuss in other lectures. Now we will be creating a EC2B machine which will be in private subnet. So here I will be going with the similar configuration which I use for EC2A. Key pair login we have already created for the previous machine, so we will be using that one only. I will be selecting this one and edit network setting. Here I want to place the machine in the private subnet, so it's fine. And to private EC2 we don't want any public IP to be assigned automatically, because we'll be doing SSH from EC2A to EC2B and it shouldn't be reachable directly over the internet. Here give your security group a name and also update the description. And this SSH default rule I won't be needing as of now, so if required we will be creating it later. So as of now I will be removing this. Rest of the configuration settings I will keep it as a default and click on launch. So here one EC2A is running and EC2B is currently initializing, so it will take a couple of minutes and now you can see it's running. Here are some points about NAT Gateway which you might want to read it. Now from the services menu, go inside the VPC and it will take me to my VPC dashboard. And from the left hand side menu, I will go to the Internet Gateway under Virtual Private Cloud. So here I will be giving some name and click on create. Then I will be attaching it to a VPC. So Internet Gateway is a VPC component which is highly available and which allows communication between the VPC and the internet. And also there is no charge for it, and you can add only one internet gateway to each VPC. Now click on attach VPC and select our VPC and click on attach internet gateway. Now we'll go to the root tables and modify the roots so that we can access our public EC2 machine, that means EC2A. So here I will be creating a new root table. Let's name it as a public RT or public root table for better understanding in the future. Select our VPC and click on create. Here I will be creating one more root table. So this one will be the private root table. Select the VPC and hit on create. Now we will be attaching our or associating our root tables with the respective subnet. So I will be associating public with the public subnet. So go to the subnet association by selecting the root table and click on edit subnet association. Here select the public subnet and click on save association. Now we will do the same exercise for the private root table and will be associating it with the private subnet. Now our root table association is in place. Now we will be defining the respective roots. So select the private public root table. So first select the public root table and go to the roots. And here you can see one root is already present that mentions the destination as the CIDR range of this particular VPC. So this is the route to communicate within the VPC. So click on edit routes and here we will be adding more custom routes. Click on add. Here destination we should be choosing anywhere, that means 0000, and the target type should be our internet gateway. So as soon as you select internet gateway, automatically the name will come, and select that and click on save changes. Now there is a route for the communication from the outside world. And also in security group, we have already allowed the communication to our EC2 instance. So now we'll try to SSH into our public EC2A machine. And to SSH into the EC2 machine, first we have to change our PEM key to the PuTTY compatible private key format. So here open PuTTYGen and click on load and select your downloaded key pair. I will be leaving key passphrase as blank. So key passphrase is an extra layer of security. Even if someone gets hold of your private key, then also key passphrase needs to be entered to use that private key. But with the use of passphrase, it restricts the automation options. So we are leaving it as a blank and click on save private key. And we'll be saving the private key in the PPK file format. And click on save. Now I will be selecting EC2A machine and copying this public IP of that EC2A machine. Also, if you click on connect, so it will give you the various method by which you can connect to the particular instance. So if I click on SSH client, it is giving me this. I should be using this particular user, that means EC2-user, and with this public IP or private IP. So here I will launch putty software in my machine and put public IP, and then from the left hand menu I will go to the credential, SSH, auth, again to the credentials, and then here I will be selecting the private key file. Here select our PPK generated file and click on open. Accept. Now we have to give the user, so which we have already seen. The user to connect to this machine will be the EC2-user. So now I'm in this machine. So if you see, IP of this machine ends with 212, and here private IP of this machine EC2A also ends with 212. So that means I'm in the correct machine. Now if I select EC2B and click on SSH client connect, then this is the method. So here I have to save the PEM key and then change the file permission and then try to do SSH. So in my machine, if I open the PEM key in a notepad and do a control and control A, control C, and open the nano editor with the respective file name. So I will copy the file name from here instead of typing. And will be pasting it here. And control X and save. So I have my PEM key in place. Now I will be running check mode command. So I will copy this complete command and paste it here and press enter. This is done. Now I will be doing the SSH. So here I will be copying the complete command from here and pasting it here and press enter. But this doesn't seem to work. So any guesses why? I'm sure many of you might have already guessed it. We don't have any security group exception in our EC2 firewall. That means in our security group which is associated with our private EC2 machine. So there we have to add one security rule to allow SSH communication from EC2A. So which we will be doing now. Going to my EC2 dashboard in AWS portal and then going to the EC2B instance and selecting that, and under security I will be going to the respective security group. Click on the security group, and here I will be clicking on edit inbound rules. Here there is currently no rule, so here we have to add the rule to allow communication from our public EC2 machine. So here I will be clicking on add rule. Here type should be SSH and source should be custom. Here I will be selecting the security group of that public EC2 machine. That means security group of EC2A. And click on save. Now if I go to my EC2A machine and try to do SSH to EC2B, then here you can see I am able to connect. And if you see here, the local IP is same as here, that means ending with 152. So as per our architecture, we are able to achieve what we have desired. So we have created one VPC and attached one internet gateway and deployed one machine in public subnet as well as one machine in private subnet. And then we are able to SSH into the private EC2 machine using the public EC2 machine as a jump box. So this is one of the most commonly followed best practice by many organizations and many people across the globe, where you keep your secure workloads in non-accessible machine, and if you want to access it, you give the access via any jump box. So the jump box could be a managed jump box deployed by you and managed by you, or it could be a managed service provided by the respective cloud provider. So this marks the end of this lecture on Amazon VPC and all of its major components. So I hope you liked this lecture, and you are going to follow me in my next lecture, which is on NAT Gateway and VPC Flow Log, and as well as the peering between two, that means connecting two VPCs. So I hope to see you in the next lecture, and in the meantime, also please feel free to provide your feedback on this lecture as well as on the future lectures. Thank you. Hope to see you in the next lectures. Until then, take care of yourself. Hello everyone. Welcome to your virtual instructor. Today we are going to talk about NAT Gateway. So NAT Gateway is AWS Managed Network Address Translation, which provides higher bandwidth availability and no administration. It can be public or it can be private. It supports TCP, UDP and ICMP protocols. You pay per hour for usage and for the bandwidth. NAT Gateway is created in a specific availability zone and it requires elastic IP. It cannot be used by the EC2 in the same subnet. NAT gateway requires an internet gateway, and you cannot associate a security group with the NAT gateway. You can associate security groups with your EC2 instances to control inbound and outbound traffic. You can use network ACL to control the traffic to and from the subnet for your NAT gateway. NAT gateway uses port 1024 to 65535. It supports 5 Gbps of bandwidth, which automatically scales up to 100 Gbps. If you require more bandwidth, you can spread your resources into multiple subnets while creating NAT gateways for each subnet. You can have up to 50,000 simultaneous connections for each unique destination using NAT gateway. high availability for NAT gateway. NAT gateway is highly available in a single AZ. You need multiple NAT gateways in multiple AZ if you want to achieve higher fault tolerance. So what is the difference between the NAT gateway and NAT instance? So NAT gateway is managed by AWS and NAT instance will be managed by you. Both are created in the public subnet. Both requires the use of internet gateway to access the internet. High availability NAT gateway offers in single availability zone, and you can deploy multiple NAT gateways to multiple AZs to achieve higher availability. For the NAT instance, of course, you are responsible. Bandwidth, it supports up to 100 GBs. For the NAT instance, it depends what type of EC2 instance you are choosing. Public IP address, NAT gateway requires elastic IP, whereas NAT instance support elastic IP address or as well as public IP address. In NAT instance, you have to disable source destination chat, but this is not required in NAT gateway. For the NAT gateway, you don't require any security groups configuration, but in the NAT instance, you have to make the security group configurations. You can use NAT instance as a best-in server, but you cannot use NAT gateway as a best-in server. So basically, NAT instance is an outdated concept and it will be fully managed by you, whereas NAT gateway is a newer concept and is a managed service provided by AWS, and of course it comes with a higher cost. So this is the architecture we are going to follow in our today's lab. So we are going to deploy one public subnet and we are going to deploy one NAT gateway in it, and also we are going to deploy one private subnet. Inside the private subnet we will be deploying the EC2 instance, and also we will be using one internet gateway in this particular VPC to access the internet. So by using the NAT gateway, we will be accessing internet from our private subnet without allocating any public IP to our private EC2 instance. So let's jump into our lab today for NAT gateway. NAT gateway is a service which you can use to access internet from your private EC2 machines. So for today's lab, here I am in my AWS console home, and here I am going to use the infrastructure which I have created in previous Amazon VPC lecture. So if I go to my VPC dashboard, I already have one VPC and two subnet. One is private subnet and one is public subnet. And if I go to root tables, I have public root table which is associated with the public subnet, and we have a route to the outside world as well as default route from within the VPC. And if I go to my private route table, it is associated with the private subnet, and here we only have a route which is local within the VPC. And if I go to my EC2 dashboard, here I have two EC2 instances. One is the public EC2 and one is the private EC2 in the respective subnets. Now I am already logged into my private EC2 machine. And if I try to ping google.com, I won't be getting any response. And if I do curl google.com, then also I won't be getting any response here, because we don't have a connectivity to the outside world from our private EC2 machine. So for that, we are going to deploy a NAT gateway. To create NAT gateway, go to our VPC dashboard, and from the left side menu under virtual private cloud, click on NAT Gateway and hit on Create NAT Gateway. Give it some name. Select the subnet to which you want to associate NAT Gateway with. The connectivity type public is fine, and I will be hitting on Create NAT Gateway. So till the time NAT Gateway is pending, we'll go to our root tables and we'll add root to the outside world using our NAT Gateway. So select private root table and go to the roots, click edit, and here add a root to the anywhere, and the target should be NAT Gateway. So as soon as you type NAT Gateway, you can see the ID of your newly created NAT Gateway. Select that one and click on Save Changes. And if I go back to my NAT Gateway deployment, I can see it is now available. So here I will again try ping google.com, and I can see I am getting the proper response back. And if I do curl with the google.com URL, here I will be getting the proper response back as well. So this marks the end of our lecture on NAT Gateway. So thank you for joining in this one, and I hope to see you in the next lecture. Hello everyone. So today we are going to talk about Network Access Control List. It is also called as NACL or Network ACL or NACL in short. What is Network Access Control List? So it allows or denies specific inbound or outbound traffic at the subnet level. You can use the default network ACL for your VPC, or you can also create a custom network ACL. Default network ACL allows all traffic to your subnet, but you can always add additional ACL rules to control the traffic. ACL provides an additional layer of security. So what is the difference between security group versus NACL? Security group operates at the instance level. Network ACL operates at the subnet level. Security group applies to an instance only if it is associated with the instance. Network ACL applies to all instances deployed in the associated subnet. Security group support allow rules only, but network ACL supports allow as well as deny rules. In the security group, all rules are evaluated before deciding whether to allow the traffic. In the network ACL, it evaluates all the ACL rules in the order starting with the lowest numbered rule when deciding whether to allow traffic. Security group are stateful. That means return traffic is allowed regardless of the rules. Network ACLs are stateless. Return traffic must be explicitly allowed by the rules. So let me explain it further. Suppose you are adding one security group rule to allow port 80 inbound. So automatically the return traffic, that means outbound, will be automatically allowed. So they are stateful. But in network ACL, you have to add inbound and outbound rules separately for the port 80. So that means they are called stateless. So this is the architecture which we are going to follow in our today's lab. So we have one public subnet and we have EC2 machine deployed in it, and we have one security group associated with it, and also we are going to make changes to the default NACL. Also this VPC has the internet gateway which allows the communication from the outside world. So let's jump into our lab today. So here I am in my AWS console. So if I go to my EC2 dashboard, I have one instance running. that is publicly accessible. And if I go to security groups, this is the security group which is associated by my public EC2 machine. So here I am only allowing the SSH traffic. If I go to my VPC dashboard, under the security, if I go to the network ACL, we have one default NACL which is associated with the two subnets, the private subnet as well as the public subnet. So if I see the inbound rule, all traffic is allowed, and also there is one inbound rule which denies all the traffic. But as I mentioned, it will be evaluated starting with the lowest number. So at number 100, it will stop evaluating and it will allow all the traffic. So you can see allow, and even if you see outbound rule, it says allow with the rule number 100. If I go to my EC2 dashboard again, here I am already logged into my public EC2 machine, the machine ending with 117. Here also you can see the machine ending with 117. I have already installed web server. You can use the below commands install web server on your EC2 instance. I will put these particular steps in the description of the video. So now if I try to access, I will not be allowed. So what I will do, I will go to my VPC dashboard and I will go to the security groups and my public EC2 group, added the inbound rule. Here I will be allowing the HTTP from anywhere. I can see hello world is being displayed on my web browser page. Now let's go to network ACL, edit inbound rules. Here you see that all traffic is being allowed with the rule number 80. So what I will do, I will just add one rule with the rule number 80, that means the lower number, and I will put HTTP, and here I will put deny. Now it goes into the infinite bit, so that means I am not being allowed. So now what I will do, here if I will change this number to 180 and save changes, then if I refresh the page, then I will be able to access my web page. Okay, so now let me try to help you understand in a better way. So earlier we had only two rules in our network access control list. One was the 100 with the number 100, and where all traffic was being allowed, and second was the star all traffic denied. So what was happening, NACL engine was evaluating the rules, so it was coming to the 100 and it was seeing all traffic is being allowed, so it doesn't go further and it allows the all traffic to the subnet. But what we did after that, we introduced one more NACL rule with the number 80 and denying the port HTTP. So now what's happening, NACL rule is going and seeing at the number 80 HTTP traffic is being denied. So it automatically stops and denies the HTTP traffic. In this case, we were not able to access the web page. So after this, what we did, change this 80 number to 180. 180 HTTP denied. So then what NACL engine was doing, it was evaluating from here with the lowest number, which was saying all traffic allow. So it was automatically allowing all the traffic, including the HTTP, and discarding all the rules present in the NACL. I hope I am able to help you understand in a better way. So please do leave your feedback. So let's proceed further. Here also, if I go to the outbound rules and suppose if I change it to deny. Now if I refresh the page, I won't be able to access my page. Though my response to the web server is reaching to the web server, but when it is sending the page, I am not going to receive it because I have explicitly denied the traffic in the NACL. So if you see all traffic denied. So until unless I won't explicitly allow it, it won't give me the correct result. So what I will do, I will again go to the outbound and here I will change it back to deny and save. And you can see I am able to access this particular page. So this marks the end of our lab today. So thank you for joining and do provide your feedback. I hope to see you in the future videos. Thank you. Hello everyone. So today we are going to talk about VPC peering. What is VPC peering? It is a network connection between two VPCs that enables you to route traffic between them using private IPv4 address or IPv6 address. So when you do a peering connection, so instances in either VPC can communicate with each other as if they are within the same net. Where you can create the VPC peering? You can create the VPC peering between your own VPC in the same region, in the different region, or even between the VPC in another AWS account. Okay, so let's see some peering scenarios. So here we have two VPC, VPC A and VPC B, which are connected by the VPC peering connection. We will be modifying the route table of each VPC, and we will be adding the route to the peering connection in each VPC A and B. Here is another scenario where VPC is paired with VPC B and C. So we will be adding two peering connections for B and C in the VPC A routes. And for the VPC B and VPC C, we will be adding the peering connection route to the VPC A. What is the VPC peering connection cost? There is no charge for a peering connection. Data transfer that stays within an availability zone is free, but when this crosses the availability zone, then you have to bear the charge, and you will be charged at $0.01 per GB in each direction, whether it is a ingress traffic or outgress traffic. So you can get more details from this link which I have given in this slide. Peering connection quota. So these are the quotas which are available with the Amazon peering connection. So here you see peering connection per VPC's default quota is 50 and it is adjustable, yes. And VPC peering connection request, it is 25. So VPC peering connection request is when you do peering from VPC A to B, then VPC A sends a peering request to the VPC B, and once it accepts that particular request, then only the peering connection takes place. So you can also increase that quota, and there is a third quota when VPC A will request for the peering connection. So it will remain for 168 hours. If it is not accepted or rejected by the remote VPC, then it will be expired, and this cannot be increased. So let's see how we can request the increase in the quota from the AWS console. So here I am in AWS console. Search for the quotas, and you can see quota increase requests. Click on this. Now search for our service, which is Amazon VPC. Go inside this. Now filter the service quota. Okay, so suppose you want to adjust the quota for the active VPC peering connection per VPC. Select this one and click on request quota increase. So here you can give whatever value you want and see if the AWS accept it or reject it, and click on the request. So I don't want to request for the quota increase, so I am cancelling this request. But this is how you can do it for yourself or for your organization. So let's go back to our slide. Okay, so what are peering connection limitations? So peering connection, when you create a peering connection between A and B, the IPv4 or IPv6 CIDR range shouldn't conflict or shouldn't overlap. That means suppose VPC A has the CIDR range of 10.0.0.0/16, then the new VPC B which you are going to pair with shouldn't have that CIDR range. It can have CIDR range 10.1.0016 or it could have 10.2.0016 or 172.xxx something like that, but it shouldn't conflict. It shouldn't be the same as or it shouldn't overlap the existing CIDR. VPC peering does not support transitive peering relationship. What does that mean? If you are pairing a VPC A with VPC B and suppose you are pairing VPC B with C, so that doesn't mean that VPC A and C pairing will automatically happen. You have to create a separate pairing connection between VPC and C. So this is the meaning of the transitive peering relationship, which is not supported by AWS peering connection. Okay, in VPC peering connection, VPC doesn't have access to any other connection that peer VPC may have. We already talked about the transitive peering relationship. That means if VPC B is paired with the VPC C, then it doesn't mean VPC A can automatically or VPC A will get automatically paired with VPC C. Also, if VPC B is connected by a direct connect to a corporate network, or VPC A cannot use the internet gateway of VPC B, or if it is a internet connection in a private subnet through a NAT device, or VPC endpoint to an AWS service. Suppose for example endpoint to S3, so they will not share the connections. Another limitation is VPC peering connections are limited on the number of active and pending peering connections that you can have per VPC, which we have already seen in the previous slide, where the default quota is given, and also how you can increase the request for the increase in the default quota. Only one peering connection can be established between the same two VPCs at the same time. If there is a peering connection between VPC A and B, you cannot create another peering connection between VPC A and B. Of course, you can create peering connection between VPC A and C or B and C, but you cannot create multiple peering connection between two VPCs. Jumbo frames are supported only within the same region. That means maximum transmission unit size is 1500 bytes. If I create a peering connection between VPC A and B, and if I am adding a security group rule in one of the EC2 in peering connection in VPC A, I cannot reference the security group of VPC B. So that is a limitation. This we will also see in our lab. So this is the architecture of our lab. So here we will be using the VPC which we deployed in the Amazon VPC class in the OEO region, and this VPC contain two EC2 machine, one in the public subnet and one in the private subnet. So in this class we are going to deploy one more VPC in the North California region, and we will be deploying one public subnet and also one EC2 machine inside the public subnet. Then we will be establishing a peering connection between two VPCs, and then we will be logging to the EC2 machine deployed in the North California region. We will be doing the SSH to EC2B machine, that means machine in the private subnet in the OEO VPC, by using the private IP. So let us jump into our VPC peering lab. I am in my AWS console in the OEO region, and if I go to my VPC dashboard, here I have already one VPC present, and if I go to the subnets, I have one private subnet and one public subnet. And if I go to the root table, so I have one private root table and one public root table associated with the respective subnet, and public root table allow the access from the outside as well. Now we will be going to North California region and will be deploying the VPC and also the required infrastructure. So click on VPC. and hit on create VPC. Give the VPC some meaningful name and give this VPC a CIDR range. Please ensure that this CIDR range is not conflicting with the VPC which we want to pair with. And keep the rest of the configuration as default and hit on create VPC. Now go to the subnet and let's create one subnet. Now go to the root tables, create one, and hit on create. Now I am going to associate our root table with the newly created subnet. Associate this root table with our subnet. Click on Save Association and we are done. Now in the virtual private cloud, go to the peering connections and hit on create peering connection. Here we will be creating a peering connection, give it some meaningful name. Select our local VPC which is in North California. Now here my VPC is in my account. If it would have been in another account, AWS account, then I would be choosing this option. So I will be going with my account option. Here we have to give the region of the remote VPC to which we want to pair with, and also the VPC ID of the remote VPC to which we want to pair with. That means the VPC in the Ohio region. So let's copy the VPC ID from here and let's hit on create. Now if I go back to my Ohio region and go to the payment connections here, I can see one peering connection is pending acceptance. And if you scroll down, you can see the various details of the requested VPC, from which VPC it has been requested and the region, etc. So here I am going to accept the request to create the peering connection. You can also reject the request at the same time. So now my peering connection is active between the two regions. Now if I go to my private root table and go inside roots and click on edit, I will be adding one more root here for the peering connection. So here I will be giving the CIDR range of the paired VPC. And target I will be choosing peering connection. Now it will show me the ID of our newly created peering connection. Click on save. Now in other tab, I will go back to the North California region and I will be doing the similar exercise to add a route for peering connection. Keep the CIDR range of the OU VPC here. And target should be again peering connection. Select the ID and click on save. Now let me quickly deploy one internet gateway and attach it to the VPC in the North California region. I won't be explaining it because you are already familiar with these concepts in our Amazon VPC class. Now we are done with the attachment of internet gateway as well as defining the route in the North California region. So here now I will be creating one EC2 instance in the public subnet so that I can log in into that machine from my workstation. Here I will be keeping the configuration similar as we did it for the previous machines. Here we don't have the key pair in this region, so I will be creating a new one here. We'll be needing one public IP here so that we can SSH to this machine from our workstation. Here I will be leaving this security rule as it is so that we can connect to this machine from our workstation and click on launch. We'll be using this public IP to connect to this machine. Now I am back in OEO region. So we have to add a security rule to allow SSH communication to our EC2B machine from the North California subnet. So if I go to my EC2B machine and the respective security group, click on edit, add a rule here. Here you cannot see the security group of the peer network. So you have to put the CIDR range of the VPC or the subnet. So I will be back to the North California region. And from networking, I will be going to the subnet. And from here, I will be taking the CIDR range. And will be putting here and save the changes. Now this is done. So I will be going back to North California region and will be doing the SSH to our EC2 instance in the North California. So put the public IP and use the newly created key pair, accept and connect to the machine. So we are connected now. Now we'll SSH into OU EC2B. So go to again EC2 dashboard, go to EC2B and click on connect. So we need this key. So we have already created this key in our previous video Amazon VPC. So let's open this particular key. Now let's do nano and key pair name, Control A, Control C, copy this, Control A, yes, save. We have our PEM key saved here. So now again go back to the connect method and we have to change the file permission. Copy the SSH method, click on yes, and now we have connected to 152 IP. You will see the EC2B machine is 10152. Now we are able to do SSH in the EC2 instance under the private subnet in a paired VPC. So this marks our end of this lab. I hope you have enjoyed it. Please do provide your feedback. Thank you for watching and I hope to see you in the next lecture. Thank you so much. So today we are going to talk about VPC Flow Logs. What is VPC Flow Logs? It is a feature that enables you to capture information about the IP traffic going to and from network interfaces in your VPC. What you can do with the VPC Flow Logs? You can diagnose security groups which are over restrictive and blocking the traffic, and you can identify the issues. You can also monitor the traffic that is reaching your instance or your ENI. You can determine the direction of the traffic to and from your ENI or network interfaces. Where you can capture the VPC flow logs? You can capture the VPC flow logs in the Amazon S3 bucket or in the CloudWatch log, Kinesis Data Firehouse. What is the cost of VPC flow logs? So this is the cost of the VPC flow logs. So basically for first 10 TB it will charge $0.5 and for the next 20 TB $0.25 and so on. And what will be the architecture of our lab today? So we will be having one VPC environment. We will be storing the VPC flow logs in the Amazon S3 bucket, and then we'll use Amazon Athena to analyze the VPC flow logs. So Amazon Athena is an interactive query service that makes it simple to analyze data directly in Amazon S3 using standard SQL. So let's jump into our lab for today. So for today's lab, I am in AWS console home. I will go to my VPC dashboard. Here I have one VPC in the US East region. I will go to the flow logs and I will click on create flow log. I will give it a name. Filter type is available is accept, reject and all. So you want to track, you want to capture accept request, reject request, or you want to capture all traffic. Aggregation interval is 10 minutes or 1 minute. If you will go with 1 minute, you will have a lot of data. But as I am doing it for the short time, so I will go with the 1 minute. Destination, as I told you in the overview, that you can send the logs to the CloudWatch logs. You can send it to the Amazon S3 bucket, or you can send it to the Kinesis Firehouse, either in your account or in a different account. So I will choose Amazon S3 bucket and I have to give my S3 bucket ARN. So for that I will create a new bucket. Everything I will keep as a default, like ACL disabled and block public access, etc. Versioning disabled, and I will hit on create bucket. Now my bucket is created. I will go inside the bucket, will go in the properties and will copy the Amazon resource name. We'll paste it here. Log record format, you can either go with the default format or you can go with the custom format. So here you can capture different things like the ENI ID, that means interface ID, what is the source address, destination address, port, and protocol, etc., and the size of the packets, and also the start and the end time. Log file format, I will go with the text default. Packet, I don't want to use it with the bunch of packets, so I will go with the text. I also don't want Hive compatible. I will hit on create flow log. So if I go back to my bucket, so here one folder is automatically created, that AWS logs, and currently there is no data captured. So it will take some time. In the meantime, what I will do, I will go and spin up Amazon Athena. So here I will go to the service and click on Athena. Here it is giving me the message that you need to set up a location for the query result. So I will click on edit settings. So here I have to give the S3 bucket URL, select my bucket, go inside it, and here I will create a folder with the name, say Athena results, and will create a folder. I will copy the S3 URL, and here in the setting I will give the URL and click on save. Now I will go back to the editor. So here I have 0 tables. So first we need to create the table to analyze the data. So what I will do, I will go to my web browser and type VPC Flow Logs Athena. I will open up the Amazon Docs link. Inside this I will scroll down and will copy the query create table statement for Amazon VPC Flow Logs. We'll copy this and paste it in my editor. So here I have to give the location of the logs. So what I will do, I will go back to my bucket and go to AWS logs folder, and here the data is generated. I will go inside this folder and US EC2. So we need data up to the region code. If you see, the location required is up to here. So what I will do, I will copy the S3 URL and will paste it here. Now I will execute the query. Now query is executed successfully, and you can see the table has been generated with the name VPC Flow Logs. Now what I will do, I will go back to the AWS documentation, and here I will copy the alter table query. So this is a quite manual process, but I will tell you the automatic way in one of my future videos. So let's paste this query. So I have to modify the date. So today's date and today's month and today's date, and here I have to give the location up to YYYYMMDD. So what I will do, I will go back to my bucket, will go inside this month, and I need the location till here. So I will copy the S3 URL and will go back to the editor and will replace this string with my location. Now I will execute this query. So query completed successfully. Now I have to select the data which I want to view. So I will copy one of the select statement from the AWS documentation and will go back to the query editor. Here I will modify the date and execute the query. So here you can see the all the query complete result, the version, account ID, interface ID, source address, destination address, etc. Even you can short it accordingly as per the parameter you required, or even you can download it if you need. Now I am done with this lab, so I will be cleaning up the resources. So first I will delete this table. As the next item, I will go to the settings and I will remove the URI S3 URI, and now I don't want VPC Flow Logs, so I will go to my VPC dashboard, go inside the Flow Logs, and here I will be deleting the Flow Logs. Also in my bucket, I don't want these folders, so I will be deleting those as well. Okay, so these objects have been deleted. So this marks the end of our lab today. I hope you have enjoyed today's session and learned from it. Please do provide your feedback. I hope to see you in the future videos. So thank you for joining and have a good day ahead. Thank you. Hello everyone. Welcome to your virtual instructor. So today we are going to talk about NAT Instance. So what is NAT Instance? A NAT Instance provides network address translation. So you can use the NAT Instance when you want your resources which are residing in a private subnet to communicate with the destinations which are outside your virtual private cloud, such as it could be the internet or it could be some resources on the on-premises network. So this is frequently required when suppose you have some EC2 machine in your private subnet and you want to download the patches from the internet, or you want to communicate the private EC2 instance with outside world or to any third-party software. So you can take the help of NAT Instance. So though NAT Instance is the outdated concept, and today most organizations prefer to use NAT Gateway, which is a managed service provided by AWS. But still, some organizations prefer to use NAT Instance. So this is a typical architecture which we are going to follow in today's lab. So we are going to deploy a VPC, and inside the VPC we are going to deploy the one public subnet and one private subnet. And we are going to deploy one NAT instance in the public subnet, which will be able to communicate to the outside world using the internet gateway. And also we'll be deploying one EC2 instance in the private subnet, and also there will be one EC2 instance in the public subnet, so that we can SSH into our private EC2 instance. So let's jump into our lab for today. Here I am in my AWS console, and if I go to the VPC dashboard, I already have my VPC deployed. This I deployed for AWS VPC lab. Also, I have two subnets already deployed and associated with this VPC. One is the private subnet and one is the public subnet. Private root table allows only the communication from the VPC, and it is associated with private subnet. And public root table allows the communication from the VPC as well as from the outside world through the internet gateway, and this table is associated with our public subnet. Also, if I go to the EC2 dashboard, so public EC2 is deployed in the public subnet and private EC2 is deployed in the private subnet. So let me connect to my private EC2 via my public EC2 machine. Okay, now I am able to connect to my public EC2. Now I will be connecting to my private EC2 instance. So I have already followed all these steps in my previous lab. So if I go to my private EC2 instance, here the IP is ending with 145, and here also you can see the IP is ending with 145. Now we'll launch the NAT instance. So give it a name and select the AMI. So click on browse more and type NAT here. Go to the community AMIs and you can select any version here. I will be going with the 64-bit Linux AMI. Here I will be using the existing key pair and will be editing the network setting. Here I will be changing it to public subnet and we will be needing one public IP. So I will be enabling this and here I will be creating a new security group. And here I will be adding some security group rules. First one will be HTTP traffic. And the source will be from within the VPC. That means VPC CIDR range. That means local traffic. Now, in the similar manner, I will be creating for HTTPS. And again, the source will be the same. That means within the VPC. And here I will be creating for ICMP traffic to test the ping command. Again, the source will be the same. That means within the VPC. That means VPC CIDR range. Keep everything as a default and hit on launch instance. Now our NAT instance is ready. Now we'll go to the VPC dashboard. And here I will be going to the private root table and roots, edit, and here I will be adding a new root. So destination for the outside traffic should be via our NAT instance. So select NAT instance and click on save. Now if I try to give again the ping command, then I won't be getting the response again. Because still one more thing needs to be done. So here go to our EC2 dashboard and select our NAT instance. And click on actions. And here click on networking and change source destination check. To use this machine as a NAT instance, we have to disable the source destination check. So you should be disabling the source destination checking when the source or destination is not itself and it is sending the traffic on some other instance behalf. Check the stop checkbox, click on save. Now let's try that. Now as you can see, we can ping google.com. Now if I do curl, so you can see the result of the curl from google.com. So this marks the end of our lab. Now let's remove our resources which we don't need it further. So let's terminate our NAT instance. Now go to the VPC, go to the root tables, go to the roots, and now go to the security groups. Okay, so this marks the end of our session today. So thank you for joining and I hope to see you in more videos. Thank you and have a good day ahead.